Welcome to SolidCAMProfessor. I'm Sydney, your SolidCAMProfessor, and in this session, we'll be showing you how we use HSM for micro milling of very small parts. Now, in this part itself, we can take a look and we see there is text that has to be put into here. However, this text has only 0.1 millimeters in width over here, that will allow us to only use very small end mills, and this cannot be done by regular milling operations. Therefore, we must create an electrode to give the negative of these texts over here. And in order to do that, we must use very small tools to get the proper text width in there as well. We can now use, with the improved algorithms in SolidCAM, both our HSM and high-speed surface modules in order to do this. In this sample, we'll be showing you how we do this using our HSM module. Now, as I've said, in order to put that text in, we've created an electrode as shown over here. And these are all the operations that we've done in order to create this electrode. But before we go into the operations themselves, let's first take a look at our tool table. We'll open up our tool table, and as you can see in our tool table, we'll be starting off using a 6 millimeter end mill, and we'll be going all the way down to a 0.1 millimeter end mill. Previously, with HSM, we were only allowed to go to 0.4 millimeters in diameters of an end mill. Below that, the algorithm would not support it properly. However, today with our improved algorithm, we can go as small as 0.02 millimeters in diameter of the tool itself. In this particular case, our smallest tool that we'll be using will be a 0.1 millimeter end mill. We'll start off by taking a look at our simulation of the operations that we've done over here, and we'll use our solid verify simulation to show the part as it's being machined. We'll start first by the profile operation that we've done around the part, and then we'll be doing the rough machining of our HSM and the combined semi-finishes around the part itself. And as we go further and further down within our operations, you'll note that we're using smaller and smaller tools as we're going around. Because as you can see, we're both milling on all sides of the end mill and getting to every single area with this particular tool allows us to get into. And then as we're going down now, we're using a smaller end mill to get even further into the part. And this is necessary in order to get ourselves as close as possible to the final finished area of the part itself. As you can see now, we've gone to the next step to get even further down, and as you see, slowly but surely, the text is now starting to appear on the part as it's being machined down. We're still not at our smallest tool. We still have two more operations that we still have to do. But every single time we do this, we get closer and closer without breaking our end mills to get to that final destination of using that 0.1 millimeter end mill as we go around. Now we're doing the parts in between the slots over here in order to break away all those material that we still necessary to get in. And then after this next operation, we will get down to this end of this operation, getting ready for our 0.1 millimeter end mill. Now that we've finished this up until the very last tool, let's take a look at the last operation that we've done over here. If we open up the operation, you'll see that the tool that we'll be using will be a 0.1 millimeter end mill. But let's go back into our geometry and let's take a look at our tolerance. You'll note that we're now using 0.5 of a micromillimeter in order to get the accuracy needed in order to work with these small end mills. We can go down now as low as 0.1 micromillimeter in order to get as accurate as necessary for these small end mills. When working with small end mills, you must make it as accurate as possible to get a good finished surface. Thank you for joining us on SolidCAMProfessor. Take care and have a nice day.